Welcome guys to another video from Data Solve. My name's Christian Lofts, and in today's video I'm going to recount my experience on an SQL interview. Now unfortunately I didn't get the role, but the reasons I'm providing this video is that so people at home can learn from their mistakes, or if they're about to take an SQL interview, they may be better prepared to do so. So with that said, grab your cup of tea, coffee, preferred beverage of choice. Today's beverage is cinnamon, turmeric, ginger, and nutmeg. Cheers to that. Let's get into it. Okay guys, the technical test for a software engineer, data engineer, fill in the blank engineer is the most dreaded test possible. And the reason is because you're under pressure to deliver an accurate result. Now, obviously with practice, these things become better. So as I mentioned at the start of this video, I'm going to actually show you questions from an SQL interview that I recently participated in. I actually have created a blog post in which I go through these questions and the logic there. If you would like to try and solve these questions before looking at the answers, you can do so by looking at my blog post. But with that said, let's jump into the actual schema of the technical test. So as you can see here highlighted in my blog post, this is the schema of the technical test. There are three tables: orders, returns, sales manager, and we can see the necessary primary keys and linking foreign keys to the necessary table. Okay guys, so here are the 5 questions that I was asked on my technical interview. Now, if you would like to try and solve this on your own, I recommend doing that. I've got the create table statement on my blog post, but if you want to follow along with me, you're more than welcome to do so. So let's start with question number 1. So sales managers with the highest sales in 2023. If you recall the schema, you need to understand where the joins are. So I know this table schema, so select all from DBO dot orders. I'll put the alias there, which is the O. Join, we'll use an inner join DBO dot sales manager SM, the alias, on sm.region equals o dot. This is the linking join for this in order to incorporate sales managers into the query. And then we need the highest sales. So in order to do so, we need to find the sum of sales. So that's the mathematical formula that we need. So we'll get the person and then sum, and we should have sales in this as sales, and we also need to put in the group by sm.person. That query will give us the actual person and the sales, but the question is asking for the highest sales in 2023. Now we need to filter for the year, I need to make sure that it's in the right order, where order's there. And then we need to make sure we're grouping by, and then we're ordering descending. So this will effectively give us, we're filtering for 2023 and we're ordering by sales, but the question is asking sales manager with the highest sales. So we need to only return one value. So we use the top one, and this will give us the answer for question 1. Pretty easy. Okay, so the next question is most returned products by category. So select all from orders, O, and we're going to use the inner join, DBO dot returns R on R dot order ID equals O dot order ID. Okay, so now we've created the basic join where R dot returned equals 1. So this query basically will tell us all the items from the order table that has been returned. Furthermore to that, we need to return the top 5 most returned products. Acquire the product name, count comes after where. Products. Now they've only been returned once, so this data set isn't that rich, but it doesn't matter because we can actually still write the query for what it's asking. So the top 5 most. So we need to select the top 5. Select top 5. So this is the final touches on this query. So if this data set was more rich, it would return, the return count would be a lot higher than what it is now. So hopefully that makes sense. We have the top 5, the returned, and we are joining on the return table. And that's basically it for question number 2, the top 5 most returned products. So the question number 3 is asking profit proportion by state. Now, before we jump into this question, let's try and understand what it's actually asking. So the profit proportion, so we need to gather the profit per state divided by the total profit in the entire data set. And then we need to turn that from a decimal to a percentage. So let's start with the query. So select all from DBO orders with the alias. This will give us everything. Now in this table, there is profit and there is state. So we'll sum here. Okay, so what we're doing now is we are gathering the profit per state, but what we need is we need the profit for the entire data set. I'm going to write that in a separate CTE. So select sum profit as total profit from DBO to orders. Oh, so this is the total profit from the whole data set, which is the value that we need to finalize the calculation. Now, how can we integrate this CTE? So the way we can do that is with a cross join, because with a cross join, we don't need to provide explicit identifiers. The cross join will practically join on any related row. So I'll show you now. So select state from group by. So let's cross join CTET. So then let's finalize this. So now the formula will be the sum of profit divided by total profit. Put it in brackets. This is just how I've learned in high school. Times by 100, as we also need to make sure that we are filtering for the year in here as well, where order date is equal to that. I'll just rename this column sum profit as. So now this query will make a little bit more sense. So we've got the state, we've got the profit for the state, and this is in proportion to the total data set, 12%. So that is the answer to question number 3. So before I move into question number 4, just to recap that, what we did is we calculated the total profit in an individual CTE. Then we linked that to the main query using a cross join. We don't need to use an identifier. Cross join is, I guess, an easy way to join tables. And we needed to filter based on the year. All right, so let's go into question number 4. Markets and regions with profit margin greater than 4%. All right, so before we jump into that, what is profit margin? So profit margin would be sales minus wholesale cost. But in this circumstance, we don't have those columns. So the columns we're working with, we do have profit and we do have sales. So to work out profit margin, we would need to, it would be the sum of profit divided by the sum of sales times 100. So let's, obviously in the correct market and regions. So let's, okay, that'll give us what we need. Okay, so this is the base query. So then what we need is the sum of the profit divided by the sum of sales, put it in brackets, times 100 as basically the profit margin formula for this. So sum of profit over sum of sales, and this will give us the profit margin. Now to finalize this question, it is asking for greater than 4%. So what we need to do, we can put in a having clause. Now because for some reason SQL, we can't explicitly use this column name, so we have to copy and paste this. It's a bit annoying. Doesn't look nice, but it is what it is. Greater than 4. So this will filter. In this case, the data set doesn't have any profit margins less than 4, so everything will return. But if it did, then this query would successfully return the desired outcome. So that's the answer to question number 4. And the final question, average days between orders per sales manager. I guess maybe you can say it's the most difficult. So what is this question asking? So we need to understand the number of average days per order for each sales manager. So let's start simple. So let's start with a select all from DBO orders, which will give us the baseline data. Then we'll filter down the columns, and we need to obviously join on the manager because we need to know the manager's name. Okay, so now we've got the sm.person o.order date. So this is the baseline query where we can, obviously this will show us the information here. Let's order by person first, then order date, just to kind of make the data look a little bit better. Okay, so now, but going back to the question, it's asking for the average days between each order. So we basically need to calculate the number of days between this guy, and then find the average of that entire column, of that entire partition for that manager. So we can use what's called the lead windows function to get the next order date. So let's jump into that. So partition, because we need to provide a partition by SM person because it's by manager, order by, and we probably don't need this ascending because by default it is ascending. Okay, so let's have a look at that. So this is the order date. This is the next order date. So now we need to find out the difference between this date and that date. So let's put in the function date diff. I believe we need day first, and then we need the starting date first, which would be the order date. Then we would need we're going to copy this and put it in here. Close the bracket as date diff. All right, cool. So now we've got the date difference. So now all we need to do is get the average of this column. So what I'm going to do is I'm going to put this into a subquery. Select all from A, and we need to remove this order by because we'll change that. Select all. So I've put this in a subquery so I can use the where clause where date diff is not null. Okay, so this is I'm just cleaning things up with this query. So now we've got the date difference. So now we need to get the average. So select. Let's remove this order by because we don't really need that. All right, so here it is. This is the answer to the final question. So average. All right, so that's the answer to the last question. And that's basically been it, guys. So if you enjoyed this video, don't forget to subscribe, like, tell your friends, and I'll see you on the next one. Thank you.